Imagine sitting down at a new Italian restaurant, right? You're out with some friends, you're starving after a long wait, so you just gorge on this complimentary pesto loaded with pine nuts.
Oh, yeah, the best part of the meal.
Exactly. And then you follow it up with a massive plate of cheese ravioli. It's a fantastic night out. But 4 days later, you wake up in the back of an ambulance.
Wow. Okay, that took a turn.
Yeah, a dark turn. The right side of your body is completely paralyzed, you can't speak, and doctors are rushing you into a CT scanner because you're having a massive stroke.
Which sounds completely hypothetical, like something out of a medical thriller.
But it's not. That is the exact sequence of events that happened to a 60-year-old man named Tony Shuggart. And the culprit wasn't food poisoning or, bad genetics acting alone. It was this invisible collision between a simple bowl of pasta and a life-saving medication.
It's crazy because Tony's story actually exposes one of the most volatile balancing acts in modern medicine.
Right.
We're talking about a drug that prevents fatal blood clots, but it relies on a biological mechanism so fragile that literally a side salad or a simple heartburn pill can just completely derail it.
So today we are doing a deep dive into a fascinating stack of medical sources to understand exactly how this happens. We've got the latest clinical guidelines from Up to Date, some incredibly dense pharmacokinetic studies mapping out liver enzymes, and of course, Tony's terrifying case report.
It is a wild case.
It really is. Our mission today is to unpack the science behind warfarin, because for decades it's been the gold standard blood thinner for millions of people globally.
But managing it is basically like walking a biochemical tightrope blindfolded.
Exactly. And to understand why Tony ended up in that ambulance, we first have to look at the battlefield inside his chest, which starts with a condition called atrial fibrillation, or AF.
Right, which is the most commonly treated cardiac arrhythmia in the world.
Yeah.
So to visualize what's going wrong here, you can think of the human heart as this intricate, super reliable electrical grid.
Okay, I like that analogy.
For most of us, that grid fires with perfect synchronized rhythm.
Yeah.
Right? Day in and day out, pumping blood smoothly through the chambers and out into the body.
But for someone with AF, it's like a storm hits that electrical grid. The signals start misfiring.
Right.
And the upper chambers of the heart, the atria, they stop squeezing powerfully, and instead they just sort of quiver.
Yeah, and when the heart quivers instead of pumping, blood just doesn't move efficiently. It starts to pool in the corners of those chambers.
It stagnates.
Exactly, it stagnates. And human biology dictates that stagnant blood loves to clot.
Which is terrifying.
It is, because if one of those clots forms, breaks free, and travels up the arteries to the brain, it blocks the oxygen supply. And that is a severe, often fatal ischemic stroke.
Okay, so the medical objective is obvious, right? Stop the blood from clotting so easily. And for a very long time, the main weapon doctors had for this was warfarin. But reading through the clinical mechanisms in our sources, the way this drug actually works is fascinating. It doesn't just attack the clots directly, it goes after the supply chain.
That is the perfect way to describe it. It's a supply chain saboteur.
Yeah.
And it all comes down to vitamin K. Your body desperately needs vitamin K to manufacture and activate these specific proteins called clotting factors.
Specifically factors 2, 7, 9, and 10, right?
Exactly. Good memory. Without vitamin K, those proteins just float around in your bloodstream, totally deactivated. They're useless. They can't bind to cell membranes or form a physical clot.
So your body has to constantly supply vitamin K just to keep the emergency clotting system armed and ready, for a paper cut or whatever.
It does. But human biology is incredibly efficient. Vitamin K wasn't always easy to find in ancient diets, so we evolved a way to conserve it. We don't just use a vitamin K molecule once and throw it away.
Recycle it.
Yes, we recycle it. Deep inside the liver, there's this specific enzyme known as VKORC1.
Okay, VKORC1. So this is like the recycling plant for our clotting glue.
Exactly. Its entire job is to take the used up vitamin K, chemically refresh it, and send it back out to activate more clotting factors.
And this is where warfarin enters the picture, because the pharmacokinetic studies show that warfarin molecules travel straight to the liver, find those specific recycling enzymes, and basically act like dummy keys.
That's a great visual.
Yeah, they just wedge themselves into the machinery of the enzyme and get stuck, physically jamming the gears.
Right, and the structural chemistry there is actually quite elegant. Warfarin uses a specific T-shaped molecular stacking interaction.
Oh, right, at an amino acid called tyrosine 139, or Y139.
Yes, Y139. The drug perfectly mimics the shape the enzyme is looking for. So once it locks in, the recycling plant shuts down. The used vitamin K piles up, the body runs out of active clotting factors, and your blood's ability to coagulate just drops.
You block the plant, you stop the clots. In a vacuum, that sounds incredibly straightforward.
It does.
But the studies make it very clear we don't live in a vacuum. We live in a world of staggering genetic diversity. And this is where that tightrope starts to wobble.
Oh, definitely. The literature shows that about 50% of the variation in how a patient responds to warfarin is purely genetic.
50%.
Yeah, 50%. It comes down to the blueprints your body uses to build those recycling plants in the first place. Some people are born with specific mutations in the VKRC1 gene.
Like the, what was it, the negative 1639G to A variant.
That's the one. And practically speaking, that mutation means a patient naturally produces far fewer of these recycling plants from birth.
Okay, wait. I want to push back on this for a second. Because if someone genetically has fewer recycling plants, wouldn't they need fewer protesters, like fewer warfarin molecules to shut the whole system down?
Exactly. They require a significantly lower dose of warfarin.
So does that mean doctors are basically guessing the dose until they test the patient's genetics?
Unfortunately, yeah, it often starts as an educated guess. Because if a doctor doesn't know about that mutation and prescribes a standard dose, they could shut down the patient's clotting entirely.
Wow.
But the genetic lottery doesn't even stop there. There's an entirely different set of genes, the CYP2C9 genes, that control the liver's cleanup crew.
Right, the enzymes responsible for clearing foreign chemicals, like warfarin, out of the bloodstream.
Exactly. So one genetic pathway controls the target the drug is trying to hit, and another completely separate pathway controls how fast your body actively destroys the drug.
That is wild. So if your cleanup crew is genetically sluggish, warfarin builds up to dangerous levels. But if they're hyperactive, they filter it out so fast, you're left unprotected from a stroke.
Precisely. You have these invisible biological dials turned to completely unpredictable settings in every single patient.
Which perfectly sets the stage for Tony Shuggart.
Yeah.
Because Tony's case study shows us what happens when you take this incredibly fragile system and just throw it into the chaos of daily life.
Tony is the ultimate example of this clinical tightrope. He's 60 years old, he has atrial fibrillation, but crucially, he also had a mechanical heart valve implanted 6 years prior.
And mechanical valves are notorious for causing clots, right?
Extremely notorious. The body recognizes the artificial material, the stagnant blood pools around it. It's a recipe for disaster.
So his doctors put him on warfarin, and they monitor his INR.
Right, the international normalized ratio. It's
Yeah.
just a universal metric for how long it takes blood to clot.
Just to give some context from the up-to-date guidelines, a normal person walking down the street has an INR of about 1.0. But for Tony, his medical team needs to keep his INR carefully balanced between 2.5 and 3.5.
It is a razor-thin margin of error. If he drops below 2.5, his blood is too sticky, stroke risk. If he creeps above 3.5, his blood is too thin, internal bleeding risk.
Right.
To hold him on that line, he takes 5 milligrams of warfarin every single day.
Okay, so his genetics and his dose are in harmony. But then he gets sick. Tony develops a diabetic foot ulcer, and his doctors prescribe an antibiotic called rifampin.
Yep.
And I looked into this specific antibiotic. Rifampin is essentially a chemical alarm bell for the liver. It's a massive inducer of those CYP-TC9 cleanup enzymes we just talked about.
A massive inducer. The liver receives that alarm signal and just goes into overdrive. It aggressively manufactures more and more of the enzymes that filter out chemicals.
So the cleanup crew multiplies overnight.
Exactly, and they start sweeping the warfarin out of Tony's bloodstream at an unprecedented rate.
So his warfarin levels plummet. The dummy keys are being yanked out of the recycling plants.
Right.
But that is only the first half of the disaster. Because a day after he leaves the hospital, he goes out to that Italian restaurant. He eats the pesto packed with pine nuts and the massive plate of cheese ravioli.
Which, under normal circumstances, is totally harmless. But pharmacologically, pesto and aged cheeses are incredibly rich in vitamin K2.
Wait, I always thought vitamin K was just the stuff in, like, leafy greens, spinach, kale.
Well, that's vitamin K1, which comes from plants. Vitamin K2 is slightly different. It's synthesized by bacteria, and is heavily concentrated in fermented foods, especially aged hard cheeses.
Oh, wow.
And introducing a massive dose of dietary vitamin K2 into a warfarin patient's system triggers a completely different biological mechanism. It biologically bypasses the warfarin blockade entirely.
Because warfarin only works by blocking the recycling of used vitamin K. But Tony just backed a dump truck full of fresh, raw vitamin K2 directly into his system.
Exactly. The liver doesn't need to recycle anything anymore. It has an abundance of fresh materials to build clotting factors right now.
Okay, here's where it gets really interesting. Because if we look at the compounding effects here, the rifampin antibiotic has flushed most of the warfarin out of his blood. The dummy keys are gone.
Yep.
And simultaneously, the huge influx of vitamin K2 has given his body all the raw material it needs to start churning out clotting glue again.
The tightrope snaps. Just 4 days after his dinner, Tony is rushed back to the ER via ambulance. They check his labs, and his INR has plummeted all the way down to 1.3.
Almost back to a normal person's baseline.
Right. And a CT scan confirms a clot formed on his mechanical valve, shot up into his brain, and caused a severe ischemic stroke, all because of a standard antibiotic and a celebratory bowl of pasta.
It's just terrifying. But thankfully, the case report notes that Tony actually survives the stroke.
He does. The medical team intervenes aggressively. They take him off the rifampin. But because his blood proved it could clot so aggressively, they significantly increase his daily warfarin dose.
They bump him up to 7.5 milligrams a day, right? Just to force his INR back into that safe 2.5 to 3.5 zone.
Yeah, he recovers his speech, goes home, crisis averted.
Yeah.
But Tony's body is now primed for the exact opposite extreme.
Right. So we're a few weeks later now. Tony is at home on his new higher 7.5 milligram dose. He gets some severe heartburn, which, makes sense given the stress.
Totally.
He doesn't want to bother his doctor, so he just buys an over-the-counter heartburn medication, cimetidine, which most people know as Tagamet.
And to anyone else, it's a harmless quick fix. But cimetidine acts as a broad-spectrum CYP450 inhibitor.
Okay, so if the antibiotic was an alarm bell that multiplied the cleanup crew, cimetidine does the exact opposite. It basically locks the liver's cleanup crew in the broom closet.
That is exactly what it does. It physically binds to those clearance enzymes and stops them. The liver suddenly loses its ability to filter foreign chemicals out of the blood.
But Tony is still taking that heavy 7.5 milligram dose of warfarin every single morning. The drug is coming in, but it has no way to leave.
The molecules just start stacking up in his bloodstream. Day after day, the concentration of warfarin climbs higher and higher, locking down every single recycling plant in his liver.
And the rifampin is completely out of his system now, so he's taking a massive dose with zero clearance.
Right.
And 2 weeks after buying those heartburn pills, Tony is back in the emergency room. He's dizzy, weak, and he's experiencing melena black tarry stools, which is a classic indicator of digested blood. He's bleeding internally.
The ER team checks his INR, and it has skyrocketed to a deadly 8.0.
Oh my God. To put an 8.0 in perspective, his blood has essentially taken on the consistency of water.
It has absolutely zero ability to coagulate. He is suffering from massive gastrointestinal hemorrhaging. At an INR of 8.0, if he had simply bumped his head getting into the car, it could have easily escalated into a fetal intracranial hemorrhage.
He would have bled into his own brain.
Exactly.
Listening to Tony swing from a stroke to bleeding out in a matter of weeks, it just makes you look at the entire medical system differently. Like, are doctors essentially forced to play three-dimensional chess against a patient's genetics, their dinner plate, and their medicine cabinet all at the same time?
For decades, yeah. Three-dimensional chess was the only option. Patients were handed lists of dozens of interacting medications to avoid. They had to come into the clinic constantly for blood draws to check their INR.
Which requires massive patient compliance. You're asking people to become amateur pharmacologists just to survive. So what is the alternative today? Because we don't hear about pesto-induced strokes dominating the news anymore.
Thankfully, the clinical guidelines show a massive paradigm shift. The medical community developed a newer class of medications called NOACs. That stands for non-vitamin K antagonist oral anticoagulants.
The name kind of gives away the secret, right? They completely ignore vitamin K.
They leave the recycling plants alone entirely. Instead of shutting down the liver's entire supply chain, NOACs directly target just one specific downstream activated clotting factor in the blood, usually factor XE or thrombin.
So if warfarin is like a biological carpet bomb that takes out the whole factory, NOACs are a biological sniper rifle.
Exactly. They just remove one specific step in the assembly line. And because they don't interact with vitamin K, the dietary restrictions just vanish.
You can eat all the spinach and pesto you want.
Eat the cheese, eat the pesto, it won't bypass the drug's mechanism. And while they still interact with the liver, they don't rely nearly as heavily on those highly variable CYP cleanup enzymes either.
So you don't have to play the genetic guessing game, and you don't panic over a heartburn pill.
Right. The data strongly supports the shift. NOACs offer comparable, often better effectiveness for stroke prevention and a much safer profile when it comes to major bleeding.
Which is an incredible relief for millions of patients. It gets them off that tightrope.
It really does.
But even with safer drugs out there, Tony Shugart's case leaves this lingering sense of unease.
Oh, absolutely. It forces you to respect the invisible metabolic machinery running constantly beneath our skin.
Yeah, because we tend to think of food as just fuel and over-the-counter pills as harmless conveniences. But this deep dive really makes you look at your own medicine cabinet differently.
For sure.
I mean, if a single genetic letter can change how your organs process a life-saving chemical, and a simple bowl of pasta can inadvertently trigger a stroke by bypassing a medication's chemical blockade, it makes you wonder, how many other seemingly innocent daily habits or quick fix pills are silently warring with our biology right now?